Welcome back, class. Thank you for joining me for our second notes in 5.3. So today we're going to talk about two more factoring techniques that we can use to solve these polynomials. So the first one we're going to discuss today is a technique called factoring by grouping. So factoring by grouping. This only works when you have four terms that you're looking at. All right, so that's the key. Now, when you have those four terms, the first thing you're going to do is group those together. Okay, so we're going to make two separate groups, one out of the first two terms, one out of the second two terms. And now we factor out individually whatever we can. So from my first parenthesis, I can take out an x squared. That's going to leave me with an x plus 2. From my second parenthesis, I can pull a 5 out. So I do that, and I'm left with that same x plus 2. Now that's kind of the secret here, is when we pull it out, we need those parentheses to be the same. And now how do we factor from here? Well, essentially I'm going to be pulling out that x plus 2 from both terms. So I take that parenthesis that's the same, and I combine it into a single parenthesis. Now what's left behind once I take out that x plus 2 from both of those is I'm just left with those leftovers, if you will, in my second parenthesis. So something that's not too difficult, however, just a new way of thinking of this factoring process. All right? So once we've done that, now we solve these. So this piece gives me an x plus 2 equals 0. So I have x equals negative 2 as a solution. And then just like in our previous notes, now we have a squared term left. So I'm going to solve this by square rooting. So I subtract the 5 over, square root both sides. Now remember, when we're square rooting, we're getting an imaginary solution. So this is really plus or minus I square roots of 5. We have those two imaginary solutions. So that's how we get our three solutions for this problem. And again, that's really our goal. Now, let's look at the next one to see if we can make sense out of this one. So again, we have our four terms. So I put my parentheses around, I group them, and now I individually am going to factor stuff out. So in my first parenthesis, notice I can pull out a 3x squared. Now 3x cubed, and I'm dividing out a 3x squared, well that just leaves me with an x. 12x squared, and I'm pulling out a 3x squared. Well, 12 divided by 3 is 4. Then the x squared is completely gone. In my second parenthesis, a little bit easier to see, I'm just pulling out a 6. But notice the key here. Notice that now I have the same thing left in both of my parentheses. So I'm going to take that x minus 4 and I'm factoring it out. I'm pulling it together. And so now in my second parenthesis, all I have is the leftovers that are left behind. And there you have it. All right, and now once we get to this point, now we have to finish solving. So we have that x minus 4 equaling 0. So we get a solution of x equals 4. Now 3x squared plus 6 we set equal to 0. And now don't forget, we have a square term and we have the constant. So we can solve this by square rooting. So I'm going to subtract the 6 over. divide by 3, and now when I square root, I'm square rooting a negative again. So remember, that means we are getting an imaginary solution. And that represents our other two solutions to this. So again, I realize brand new process, however, it is completely doable. So before I move on, please pause the video if you need any extra time to write any of this down, because I realize that there's a lot of good stuff here. Now, the second technique that we are going to talk about today. The second technique is called the sum or difference of cubes. Okay, now, this is going to be a little bit to wrap your minds around. So, please pay attention carefully. Sum or difference of cubes. This works when you have two things that are cubed, either being added or subtracted, okay? So remember difference of squares? Well, that only worked when it was a difference. This works both ways, okay? You can be adding or subtracting them. Now this time, instead of looking for the perfect squares, this time you're going to be looking for the perfect cubes. So you're going to be looking for numbers like 1, 8, 27, 64. Numbers like that are the clue now. So, looking at this, so my first example, I have two cubes, okay? Because notice, this is x cubed, and this is 3 cubed. Okay, so that's kind of the first thing to notice, is break down what is our A, what is our B. So right now, x is our A, and 3 is kind of going to be our B in this case. Okay, so looking at this, if I want to set up my formula, notice, and this one I'm adding. So I'm going to be using this formula right here. And now all I really have to do is construct that formula. So I have A plus B. Well, in this case, that means x plus 3. Then I have A squared, so x squared, minus 2ab. Well, a times b is 3 times x, plus b squared. So plus 3 squared is going to give me 9. All right. So by following the pattern, and again, I recommend whenever you're doing practice work, please have that pattern in front of you so you get used to using it. So once we've done that, well, now we need to look to see. We have a linear term, so that's already finished. Then we have that quadratic. Now, the problem is, most of the time, if not all the time, the quadratic that you're left with when you have these difference of cubes is not going to factor, okay? So the dilemma that leaves us is here, when we take this, we have our solution of x equals negative 3, which is awesome. But we also have another problem. We have this that we also have to solve for 0. Now, if factoring won't work on this quadratic, what do you think that means? Well, that means you have to use the quadratic formula. So to refresh your memory, what the quadratic formula looks like. Looks like that. So to solve that quadratic piece that is left over, now we need to use the quadratic formula on it. So we have our a of 1, b of negative 3, c of 9. So let's plug those in. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right. So remember, when we're simplifying, the first thing I want to do is get a single number under the square root. So negative 3 squared minus 4 times 1 times 9 gives me a negative 27. Now, when we're square rooting a negative, remember, we're not really able to square root a negative. So what do we do to compensate for that? We say we're dealing with imaginary numbers. Now, unfortunately, even this has a slight twist to it, okay? That's square root of 27, okay? So I'm going to do a little scratch work up here. Remember, the square root of 27 is really the square root of 9 times 3. So really, even that ends up simplifying. So we also have to recognize that that is breaking up into a 3 on the outside and then a square root of 3 left on the inside. So what that means is one of our solutions is negative 3. Another one of our solutions is that right there, the solution to the quadratic formula. That represents the other two solutions. So this one is a lot to digest, okay? Because once you do the sum or difference of cubes, now you're stuck with having to use a quadratic formula. So these do get to be lengthy problems. However, as long as you follow this process, you're looking at that formula, and then you know to use the quadratic formula, you should be able to be successful doing this. Now, let's do one more example together. So looking at this time it is a difference of cubes. All right, so notice here, this is really 2x cubed, because 8 is 2 times 2 times 2, and that is 1 cubed. Okay, so always be able to recognize those two pieces, okay? What is being cubed? Because now this is our A. Our A is 2x, and our B is 1. So, what does that mean for us? Well, I have to scroll, but you're able to see it on your paper. This time, we're going to be using that formula right there. Okay, so for the difference formula, we have A minus B, so 2x minus 1. Then we have A squared, so the quantity 2x squared is 4x squared, plus A times B plus B squared. Okay, so again, if you follow the pattern, that is able to tell you what or how it breaks up, how it factors. So now when we go to solve these pieces, 2x minus 1 equals 0, we end up getting an x of 1/2. When we set this piece equal to 0. Well, now this is going to be one of those quadratics that we need the quadratic formula for. Okay? So, our a is 4, b is 2, c is 1. So let's plug this into the quadratic formula. Negative b plus or minus b squared minus 4 times a times c, all over 2 times a. And remember, the first piece that we're going to simplify is what's under the square root. So 2 squared minus 4 times 1, that is going to leave us with a negative 12. Now, remember, because we're trying to square root a negative there, we pull that imaginary piece out, okay? We pull out the negative to say that it is imaginary. And now, again, you always have to be careful as well, because that square root of 12, the square root of 12 is really 4 times 3, so it can reduce to 2 square roots of 3. So that means we have a 2 on the outside of the square root now, and a 3 left inside of our square root. All right, now, next thing to notice, 2, 2, and 8. So notice every piece of this is divisible by 2, all right? So really, to finish the simplification process, we can divide both the top and bottom by 2 and let it reduce to that. So these represent our 3 solutions. 1 real solution and 2 imaginary solutions. Now again, I know this is a lot to take in, so we're going to do plenty of practice work in class so you get comfortable with this. But please, for now, make sure that you have everything written down, and then again in class come back and we will be ready for our practice work.